All right, sorry about that. So as you can see, I slightly changed the title of my presentation. It's more accurately Cool Season Forage Grass Palatability and Preference in Dairy Cattle. So to start off, I'd just like to explain to you the importance of palatability and preference in regards to animal grazing studies, and also make the important distinction between the two of these terms, as they're often used interchangeably, and that's not necessarily the case with the two of them. So palatability is defined as a factor that affects the animal's likelihood of consuming a particular plant and involves visual, olfactory, and gustatory senses, so sight, smell, and taste, and how the animal receives those from the plant. Preference, on the other hand, is defined as a factor that affects what animals consume when they're allowed to be selective. So this involves having a low stocking rate per unit area, and so that they're not competing with each other for the same amount or same area of forage in the pasture, and also having multiple species or multiple varieties within the same species in order to allow them to have something to select between. And so a lot of the literature has found that these two things are highly correlated to forage quality components of the pasture and the forages in them. And so, as you can imagine, this subsequently impacts voluntary intake and subsequently animal production. So for the purposes of my study, we're defining palatability and preference as the tendency of an animal to selectively graze a particular plant when multiple options are presented to them. And so, as you can imagine, there's a number of factors that have been cited that are of particular importance when in association with palatability and preference, and I'm just going to touch on a few of the big ones here that deal more with preference than they do palatability. And so the first of these is the amount of total available forage. Animals have tended to gravitate towards areas of greater forage density and forage height, and followed by that we have the amount of total non-structural carbohydrates in the plant, and that subsequently is related back to forage quality and nutritive value. And if you can see by the diagram I have over here on the side, that the purple area on that slide represents the amount of, in the later harvested forage, represents the amount of total non-structural carbohydrates in the plant. And as that plant matures, each cell has a greater buildup of the dark green area on the outside, which represents the buildup of secondary cell wall components, which subsequently reduce animal intake and lower energy by the animal, or lower energy usage by that consumed forage. So in my literature review I've come across a number of confounding factors in animal grazing studies that are often present, such as maturity variations between varieties and species that are in the field that can bias their preference from one thing to the next. Also, the use of qualitative versus quantitative data, where your qualitative data isn't necessarily applicable to someone who hasn't taken those measurements themselves, and also just forage availability differences from plot to plot not being taken into account, which make it hard to identify the best species and varieties. And so in most of the papers associated with dairy cattle, orchard grass has been found to be the most palatable forage grass to them and most preferred in many of the papers. However, some more recent studies out of the Netherlands and the United Kingdom have shown that perennial ryegrass has been more preferred by them. However, I'd argue that the climate differences between Northern Europe and the fescue belt are much different, so the growth habits of perennial ryegrass are going to differ substantially between our two regions. So the question we want to answer with my thesis research is, how does palatability differ between species and within species by variety? And so we have two primary objectives associated with this, which the first of is to determine dairy cattle's preference of forage species and variety, and we hypothesize for this that there will be a differing preference between species and varieties. And our second objective, which I'm working on now, is to compare the phenotypic traits between species and varieties to determine forage quality components. And we hypothesize that the most preferred species and varieties will exhibit phenotypes that are highly correlated with the most preferred varieties or species. And so for my grazing trial, I have quite a large number of entries, 24 varieties across 4 cool season grass species: orchard grass, tall fescue, perennial ryegrass, and festuloleums. And those are broken down into a randomized complete block design with 6 replications. And my plots are relatively small. The total area is about 1/10 of an acre, and it is set up in a traditional cafeteria-style grazing plot setup. And so in order to address that issue I mentioned of confounding maturity across all those different varieties and species, what we did was allow the plots to go into their reproductive stage of growth and then subsequently mowed off that growth in order to put those plants in vegetative state of growth before we did any kind of grazing on those plants in order to kind of knock that confounding aspect out. And so following that, we started our 3 grazing trials that we had throughout the year using Holstein yearling heifers. And so we sampled our plots for quantitative yield data before and after grazing in order to determine the percentage of forage consumed. And I also did visual ratings of the plots. However, I've not been able to statistically validate that data just because I had a hard time myself distinguishing between like a 4 and a 5, for instance, in the middle ground. And our grazing cycles were lasted over a 6-hour period of 1 day using 3 to 4 animals for a stocking rate. And for my statistical analysis, I use SAS 9.3 with repeated measures because I'll be taking the same measurements on these plots next year using proc mixed, and I set a p-value of 0.05 to determine significant differences. So if you can see from in the back, these are the 3 images of my each of my grazing studies, which represent June, July, and September, so spring, summer, fall. And the reason we did that was because we wanted to have a representative sample of grazing throughout the patterns of cool seasons, forage grasses, bimodal growth over the year. And so I just want you to notice how much lusher and denser that material is on the left and right, the spring and fall pictures, than it is in the July grazing in the middle when we were in a heavy drought situation. And so this just gives you a sense of the total grazing area that I had the animals in. They are all seem to be congregated on the far side there, but they have free reign of that area. And so for my results, my primary variable of interest here was percentage consumed. And so what you may be asking yourself right now is, why do I not have varieties here? Because my bar simply represents the 4 species that I'm using, and my statistical analysis actually showed that at least in this particular study, that when species are present, varieties don't seem to have a significant effect on their preference of one or from one plot to the next. But rather, species is highly significant and has a highly significant interaction with the time point of their grazing. So in that sense, this one graph essentially explains all the data that I have from my first year of harvest, where I have broken up each trial, and within that I have each of my species and their percentage consumed. And so we can see from the first session on the left that orchard grass was the most preferred, followed by vestibulums, and then perennial ryegrass and tall fescue was the least preferred. However, what's interesting to me is in the summer that trend has almost completely reversed itself, where now tall fescue is the most preferred species by them. And then the other 3 species are farther down, but they're not significantly different from each other. And then in our fall grazing in September, there were no statistical differences between any of the species. And so far after the first year of data collection that I've done, our first hypothesis has so far been verified that there does seem to be a difference in terms of their preferences by species. However, as I said, varieties don't seem to play any kind of significant role in my data. And our data shows us that each grazing session exists as a separate entity, so preference from one session to the next can't be directly compared. So because trial is highly significant, I can't average all the means across all of our grazings and tell you that one is good for the best average out of the entirety of the year, but rather that it's, I can only tell you which one is the most preferred from each of the 3 sessions that we had. And as I said, in the fall grazing, animals didn't seem to show a preference for one species over another. So my future plans for this study is that we will repeat it in the 2015 growing season at identical time points, if at all possible, in order to get multiple years of data for the same grazing sessions, and hopefully we'll see similar trends. And right now I'm still working on getting the forage quality data off of all the plots that we harvested this year, and we may see significant differences between varieties. I'm highly expecting that, obviously, and hopefully that will then be correlated back to their preferences based on the forage quality data. However, at this point, what I would tell producers in conclusion would be that we can't definitively state that one cool season species is going to suit you adequately for growing that crop or for your pasture all year round, but rather that you need to have a good balanced forage system design in order to allow them to have the highest intake and energy usage throughout the entirety of the year. So I'd like to thank my major professor, Dr. Tim Phillips, my committee members, Drs. Ray Smith and David Van Sanford, Dr. Ben Goff at UK for his assistance in my statistical analysis, and finally our technician Philip Shine and Ray's technician Gene Olson for their assistance in helping me harvest my plots and handling of the animals. And at this time I'd be happy to take any questions. Thank you. Yeah. Mm-hmm. Well, no, we took that off to remove the reproductive growth, and so it was in vegetative state. So then when they grazed, we harvested the day before they went on, and then after they were taken off, we harvested as soon as they were done, and then we took the difference between that, and that was determined as the percentage of total forage that they consumed. And we did that for each of the 3 grazing sessions that we had. Mm-hmm. Did you see a difference in the architecture of the plants to help explain that? I did on the first grazing. Oh, okay. He asked if I saw a difference in the canopy architecture from one grazing session to the next to explain some of those differences possibly. So I did notice from spring to fall, from spring to summer, excuse me, that the fescue growth in the spring was still very prostrate. So, and that was largely because we had poor germination in some of the fescue plots. So we had to transplant into that in order to fill the stand up. So that may have caused some of the issue with that first grazing in terms of why fescue was so low in that first grazing. And once by the second grazing session, the fescue was much more erect in its growth than it had been in the past. But in terms of the other species, I didn't notice any particular striking differences from one session to the next.
Yeah, so when you're looking at preferencing, I'm sure there's a pretty big animal influence on preference. So how did you make sure that it wasn't just because where you happened to open the gate, that's where they walked in and they just hammered this rep? How did you make sure that the distribution allowed actual measurement of preference?
I understand your question. I'm just trying to think of, well, I guess I'm not really sure what you're asking me. I kind of understand it, but I'm not sure if I'm on the same page as you or not.
Probably, Eric, the question might be for your plots in a randomized distribution in the field where maybe the animals would come in and then hit any particular, is there any bias by the location or the entry?
I wouldn't think so because let me scroll back here. What you see on the side, I have my ranges here, but each of those is not a block. It's set up more in a snaking pattern that goes through there lengthwise. This is a side view of the plots. So each of the reps is actually going this way as you're looking at that image, and it's about like 3 plots deep in there. And so as soon as they entered, they pretty much were just in a completely randomized replication wherever they happen to come into that plot at.